So the problems we're doing today, we're going to be sketching rational functions or graphing them. And without having some structure to follow, it can get really confusing. And so that's why I'm putting this here for you. So we're going to follow through these. Step one, we're going to look for a Y-intercept. Just like you do with any function, you plug in 0 for x, find it. Step two, we're going to check for a horizontal asymptote, which is what we were doing last night for homework. Okay, that's when you look at the limit as x goes to infinity. Step three, we'll factor numerator and denominator, which is something, again, we've been doing throughout this course and this unit. We'll reduce it. If it does reduce, you have a hole in your graph, and we saw that in the past too. Now it's going to matter when we're actually graphing it. Okay, and we'll see what that looks like. Finding X intercepts, set the numerator equal to 0 and solve for x. Finding vertical asymptotes. That step 6 is what we were doing in the very beginning when you were finding all those. You can't divide by 0 when you have a fraction, and you guys would write the excluded values. That's where your vertical asymptotes will happen. And then after that, then you're ready to graph. And even then, sometimes you need to test some points out. So all that we're gonna work with. It is a few steps, yes. I thought, before you factor, find your Y-intercept horizontal. Might be the right form.
Yeah.
Start working. So first of all, because there's so many steps, just to ease your fears, for homework, I'm going to barely give you any problems. Okay, so don't worry too much about that. And we're going to take our time to, and it also can become really, if you're not organized, these can get really messy. So I'm going to demonstrate how I want to organize these. Anybody need more time? Okay. And So step one, we're given this function. Step one is to do what? Okay, find the y-intercept. And in this form, it's easiest to find the y-intercept by plugging in x equals 0. And so, although there's no f of x, I'm just going to, f is still the same thing as y. And so I'm plugging in 0 in for x. And when we do that, we're going to get 6 minus 3 times 0 over 0 squared minus 5 times 0 plus 6. And lots of stuff will go away, and we'll end up with 6 over 6, which is 1. Okay. And why are we doing this? Well, we are finding the y-intercept, so label it y-intercept. And the y-intercept is actually a point. What's the coordinate of that point? 0, 1. And then box in your y-intercept. So that's the first thing I want you to do. Find that y-intercept. And again, I'm going to model the way I want you to organize your work. What's the second step? Check the horizontal asymptote. So this is like last night's homework. So we're going to do this. Limit as x goes to infinity, okay, of our function here. And for saving you a little time, just write f of x, which is our whole thing there. Okay, if you want, you could copy that whole thing down, but I'm okay with this. And that's going to equal the limit as x goes to infinity. This is where you cut some stuff off, right? So what can we write this fraction as? Negative 3x over x squared, okay? And then we still need to carry that limit with us. So limit as x goes to infinity. We reduce the fraction, negative 3 over x. And now once you don't have a variable, we don't have the indeterminate form anymore, because if we plug in x, we're going to end up with negative 3 over infinity, which is 0. Okay? And so the whole reason we did this was to tell us that we have a horizontal asymptote. Where? No. Y equals 0, right? Make sure you write it as an equation. So box that in. Okay, so we did step 1, step 2. What's step 3? Factor. Everything you can factor. And so we're going to factor everything we can. And we end up with y is, so in the numerator, what can we factor out? A 3. I'm going to actually factor out a negative 3, and you'll see why in a second here. If I factor out a negative 3, what's left? X minus 2. Go with that? You check it. If you multiply the negative 3 in there, you should end up back, right, if you distribute that. And then we want to factor the denominator. We're looking for two numbers that multiply to 6, add to negative 5. What are they? And we can take the shortcut, so just go x minus 3 times x minus 2. Okay. What's the next step? So reduce it if you can, right? Sometimes they'll reduce, sometimes they won't. This one will. So we can get rid of the x minus 2. And when we reduce it, what's happening here, if you cancel out a factor or reduce out a factor here, that means there's going to be a hole in the graph at that point. And so I'll show you how to note that. So here's what it looks like when you've reduced. But because we reduced, there's going to be a hole at, and to find the point, we took out the x minus 2. So you set that equal to 0 and solve for x, and you get 2. So 2 is your x value. To find the y value, you got to plug in 2 for x, but don't plug it in here because you're going to get you're going to get 0 over 0, which is indeterminate. So you have to plug it in over here once you reduced it. And that's where your hole is going to be. So plug into here to see what y is going to equal. So it's negative 3 over 2 minus 3. So the hole is going to be at 2, 3. Box that in. Okay. So we found our y-intercept, our horizontal asymptote. We found that there's a hole in the graph. Questions yet? Okay, what's the next step? Okay, X-intercept is next. So X-intercept happens when, in general, a function, you find an X-intercept, you plug in 0 for y, right, and solve. Well, if you have a fraction, what part of your fraction makes the fraction equal to 0? The numerator or the denominator? Numerator. The only way to get a fraction equal to 0 is if the numerator is 0, right? And so that's why I said to check this, you just check your numerator. There's no variables here. There's no way our numerator can be 0. And so we're just going to take a note that there's no x-intercept, which is going to be helpful when we're graphing. So even if there's no x-intercept, I want you to state it that way. And then lastly, before we graph, next step would be to find the vertical asymptotes. And that's when you take the denominator that's left, set that equal to 0. And so this is telling us we have a vertical asymptote at x equals 3. Do you want to go back to the x-intercept? Okay. There's no way the numerator could be 0. Yeah. Okay. Any questions on what we've done so far? I'm following those steps I've given you. This is all the stuff we have to find before we start to graph. And now we've found it. Now we're getting to the graph. Okay? And how I'm organizing it here is how I want to see you organize. Okay, so then take time on a nice graph. Okay, and we're going to do that. So put arrows on your x and y axes, label them x and y. Plot your x and y intercepts if there are any. So we don't have any x intercepts. We do have a y-intercept at 0, 1. I'm going to put a point there. We have a hole at 2, 3. So I'm going to go to 2, 3. Sure, just give me big enough so I can tell that it's a hole and not a point, okay? Then let's put our asymptotes in. So we have a horizontal asymptote at y equals 0. So that's along the x-axis. Label that y equals 0 in your graph. We have a vertical asymptote at x equals 3. Label that one as well. Okay. All right. So now that's our second to last step there. Our last step is now, okay, once we're here, try to graph it. Okay, try to fill in the missing parts. And sometimes there's too many missing parts, and we'll have to take some test points, and I'll demonstrate here. But here's one thing I know. There's no x-intercepts, so this thing can't cross the x-axis. That's going to be helpful in doing this. There's a horizontal asymptote, so I know as I go to this side, it's got to get closer to the x-axis. As I go to the right, it's got to get closer to the x-axis. When I get close to this thing, what's going to happen? Either has to go up to infinity or down to negative infinity, but we know which way it has to go. We have some information. It has to go through these points. Can it go back down now? Can it make a turn and go like this? Why not? because it can't cross the x-axis. So we already know it has to go this direction. And it can't cross the x-axis, so it just gets close. Okay, so we're good with that side. And that's exactly what it's going to look like. Now over here, we have some options, and we don't have enough information, so we're going to have to test it out. It could be up here, or it could be here. Those are the two options, right? And so I'm going to pick a point past 3, to see is it above the x-axis or below the x-axis. So I'm going to test at f of anywhere. I'm just picking 1 over f of 4. You could pick another value as long as it's to the right of that vertical asymptote. So if I plug a 4 in, now which one am I going to want to plug a 4 into? This one, or this one? I could pick any of them, but what would be easiest? The most reduced one, right? So that's going to be negative 3 over 4 minus 3, which is negative 3 over 1. And so when x is 4, we know y is going to be at negative 3. And so I'm going to plot that point. It's right there. So then now I know which part that is. And that's exactly what the graph looks like. Okay. And we'll finish the problem. So that's why they are long problems. You want to take your time through them, because there's lots of pieces to it. Okay. No guessing. No guessing. Okay. All right. Any questions, reflections on this one before we leave it and try another one? Yeah. Okay. So on the left side of this vertical asymptote, I knew what was happening because I had a couple points there to work with. On the right side, I didn't know if it was down in this corner or up in this corner because it could have happened either way. And so I needed more information. So a test point is just say, hey, let's pick an x value over here, plug it into the function and see where it is. And so I plugged in a 4, and I found that point is here. And there's no way this thing can cross the x-axis because there's no x-intercepts. So it's stuck in that corner. And that convinced me, okay, now I know the graph looks like this. Okay. Okay, so let's do another one. So we're just going to follow those steps I gave you. Okay. First step, find the y-intercept. So we're going to plug in 0. Go ahead and find that. What are we getting? So make sure you write it as a point. Make sure your work looks like this, that you've boxed in y-intercept. Okay. 0, negative 1. Next step, we're going to find if there is a horizontal asymptote or not, and if there is, where it is. So that's when we find the limits as x goes to infinity of f of x. So go ahead, I'm going to pause and let you try that out. So that's where you test for the horizontal asymptotes happen when you when x gets larger and larger and larger on the right side, so that we're really just checking the right side. We're not checking the left side. That's where horizontal asymptote would be. So if this limit equals 0 or some constant number, then there will be. If you get infinity, then there won't be, or negative infinity. But you're always going to check it at infinity. Is there a horizontal asymptote? Y equals 0. So this is what you want your work to look like. Okay. You want to carry the limits until you actually plug in infinity. Okay. And then once you have that, then box in what the horizontal asymptote is. Make sure it's an equation, y equals something. Okay. All right. Then you're going to factor. That's the third step. So go ahead and factor it, reduce it. When you factor it, should look like that. So you can't take the shortcut with your factoring. Got to work through it. Okay. You get x plus 3 over 2x plus 3 times x minus 1. Check if something reduces. Does anything reduce? No, and so that tells us what? No holes, so please state no holes, okay? Then we're going to check for X intercepts. So we just grab the numerator and set the numerator equal to 0. We end up with x is negative 3, so that tells us we have an X intercept where? Good. So put it as a point, box that in. All right. And we need to find one more thing before we start graphing. We need to find, or if there are any vertical asymptotes. We have 2 factors, so each one's going to give you a different vertical asymptote. And so the 2x plus 3, you set that equal to 0. You get x is negative 3 over 2, and the x minus 1 gives us x equals 1. These are the numbers that we're not allowed to plug into our function, right? Because it makes us divide by 0. And in terms of a graph, that's where your vertical asymptotes happen if they're not holes. And here's not a hole. So here we're going to say we have vertical asymptote at x equals -3/2 and at x equals 1. All right. Questions yet? Vertical asymptotes happen only when the denominator is 0. X intercept only happens when the numerator is 0. Okay, that's fine. So now we're going to move to graphing. Plot what we already have. Label your x and y axes. So we have a y-intercept at 0, -1. And we have an x-intercept at -3, 0. We have no holes. We have horizontal asymptote at y equals 0. That's along the x-axis. Label that. We have two vertical asymptotes, one at x equals 1. And one at -3/2. So if you think of that as a decimal, what would that be in decimal form? -1.5. So right here. Label those. So x equals -3/2 and x equals 1. So then it's trying to put the graph together. And I'm going to pause. I want you to try to think, try to draw it. And I mean, you could draw it really lightly because if you make a mistake, we can erase it, or you could sketch it somewhere else if you want. But I want you to try it without me first, and then I want to do it with you, okay? All right, so you got to think of your graph as 3 sections. Okay, the vertical asymptotes kind of section things off. So you have the left section, you have the middle section between the two vertical asymptotes, and you have the right section. And so when you're graphing, you want to make sure you pick a section at a time, make sure you hit all 3 sections. Is there any section that you know for sure what's happening in that? Either the left section, the middle section, or the right section? Any? Or maybe you're just like, no, I'm not sure yet. Yeah. The middle. Okay. So you know it has to go through this point. Can it cross the x-axis here? No, because that's the only place it can touch or cross the x-axis. So it has to stay down here, and it can't cross these. So you know both ends have to point down. So we have the middle part. Kind of looks like maybe like a parabola there, yeah. Okay. So that's something we know just by looking at using what we already have. That we don't need to test anything. Okay. Here, I probably need a little more information. Different things can happen, right? And so I'm going to test some stuff out over here. I'd like to know what's happening to the left of that point. So I may plug in -4. I kind of also want to know what's happening to the right because it can pass through, it could bounce at that point. There's a lot of things that can happen. And I need to be for sure what's happening. So I'm going to test it at 2 places. I'm going to test it at -2 and a -4. So I'm going to try at -4 first. And so watch what I do to test this. So I only care if it's above or below the x-axis. So I'm not going to actually go through the whole testing process. All I care is is the answer going to be positive or negative? That's what I really matters to me. And so I'm going to, if I plug in a -4 in the numerator, and the denominator I'm going to plug in a -4, I get 2 times -4 plus 3, and still one more factor, -4 minus 1, right? So what I'm going to look at here is in the numerator, I'm going to end up with a -1, right? And I'm just going to use the sign. In the denominator, I'm going to end up with, is this going to end up being positive or negative? 2 times -4 is -8. -8 plus 3 is, so it's going to be negative and a negative, right? So we're going to end up with a negative divided by a positive, which is going to be negative. So you could just think about the signs. You could also work with numbers, but this is all you need because this tells me, okay, it's below the x-axis at that point. It doesn't have to be perfect. -1 so it's really close to it, but it's right. So I'm going to put a point below it. What's happening at -2? Is it going to be a positive or a negative? Just be careful that you think through that. So here I'm going to get a positive divided by a negative times a negative, right? Which is positive divided positive. So you're going to end up with a positive value. So I know it's somewhere above. Okay. So I now have enough information to finish the left section. This right here goes along the vertical asymptote. What's going to happen as can I just keep going down? No, because I have a horizontal asymptote here. So it's going to go down and then it's going to kind of come up to it. So question here, can a graph cross a horizontal asymptote? Yeah, we just did. Okay, can a graph cross a vertical asymptote? No, but a graph can cross a horizontal asymptote, and you may not have seen that before. You may have thought, oh, a horizontal asymptote's a boundary you can't cross. You can. It won't happen that way. You can never have it. Yeah. Okay, we got one more section, the right section, and we know nothing about this side. Okay, but let me ask you this. The horizontal asymptotes give shape to the far end. So that told me that it needs to eventually come back to it. That's why. Now, how many points do I need to test over here to be sure what's happening? One. Just one. Here's why. It's not crossing the x-axis, so it's easier for me. I just need to know if it's below the x-axis or above. If it's below, it's gonna be right in this corner. If it's above, it's gonna be in this corner. So it only touches the x-axis there. That's the only one X-intercept. We only because because that's what an x-intercept is. Okay, so see if you can finish it. Pick a test point. See if you can figure out where what's going to be there. All right. Do we have something? It look like this? Okay, I tested f of 2. I picked something right to the right of that. And I said everything's going to be positive here. And so it's going to be a positive answer. Tells me it's above the x-axis, so that's what I end up with. All right. No matter where. Okay. Like, so it has, this has to come close to this. This one has to go up this way. Okay. Yeah. Okay. Step 1 is step 8. Okay. And then I will say, and then maybe I'll have you go. So try this out. Okay. And you see everybody working on this one. Okay. Organize it, make it look nice, go through the steps. These are more than what we used to do. Okay, so please make sure you organize work. I want it to look like this, okay? Your homework, just to give you, I'm going to take 2 problems. I'm going to make each problem worth 5 points. I'm going to grade it. I'm actually going to grade it. 2 homework problems. I can just see effort to be graded. If you do awful, I'll let you redo it, okay? But I want you to, I'm going to grade like that really fast. So you get to feedback. And this is what I want to see on grading. I want to see it organized this way. I want you to box in those 5 things. Okay? If there's nothing, you say just box intersection. Good graph. Okay, so any questions on this problem? Which were you able to assess? Okay. So I'm going to give you one more, and I'm going to have you as a group 2. I'm going to teach you do that, and then I'll give you yours. Okay. So that's Okay.